The one downside to a wireless network is that unless you do something, everything that you're sending back and forth is being broadcast over, well, radio waves. And a bad guy can be intercepting these radio waves sitting in a parked car with his own system, and if he knows how to do it, he can literally capture your conversations and see everything you're doing. So that's a bad thing. Now, the people who originally invented 802.11 knew this, and they came up with an authentication method which allowed you to actually talk to the wireless access point, and an encryption method which would then encrypt your data. This standard had all kinds of problems. First of all, the authentication was very, very poor. It literally would transmit passwords in the clear as part of the authentication process. So on today's wireless access points, we pretty much ignore authentication, which means anybody can talk to a wireless access point. Now, the trick is that now you have to have an encryption to get past it. The original encryption that we saw with 802.11 was called WEP. WEP was, well, I'd say it was about as useful as a tinfoil hat. The problem with WEP is that it wasn't a bad encryption in and of itself, it's just that the way it worked. You see what happens if you encrypt packets, that means you're going to have to bring a key along with every packet so somebody can unlock it. And the key has to change, otherwise people can figure it out really, really quick. So if you use the secret decoder ring analogy, the problem with WEP is that as every packet went over, they incremented the secret decoder key one click. And if you know that ahead of time, you can mathematically figure out the key, and as a result of that, WEP was a disaster. So, I mean, this was only a couple years after wireless came out that they realized that they completely had messed up on authentication and encryption. So they all got together and they were going to come up with a new standard, which they eventually did come up with, called 802.11i. 802.11i was going to have this robust authentication where even just to talk to the wireless access point, you'd have to be typing in username and passwords or retinal scanners or whatever you wanted, using all these really, really high-end standards with names like 802.1x and stuff like that. Don't worry about that. And then they were going to come up and make a better encryption. And the encryption was going to be much more robust, and it was going to be using a tougher type of cryptology called AES. So it was great. And everybody's like, oh, this is going to be great. We can't wait for 802.11i. When's it going to come out? And the industry's like, ooh, about 5 years. Well, no one was going to wait around for that. So what happened is that all the different people who were making this technology, Cisco and D-Link and Netgear and Linksys and all these guys were getting together and sitting in smoke-filled rooms, no doubt, and said, okay, what part of 802.11i can we do right now? And it basically boiled down to this. They're not going to worry about authentication. They're just going to leave it open. However, they will provide some forms of authentication for very advanced networks. And the other thing, and this was the big one, is they were going to fix WEP. So what they did is they go, okay, now we're not going to worry about authentication, that's all right, and we can fix the WEP, except the one thing we can't do is we can't add AES. AES is a really powerful encryption standard, and it really requires new hardware. And we wanted to come up with a fix, which we could, through a software fix, be able to take care of that. So the industry got together and created something called WPA. So WPA was really nothing more than all the parts of the 802.11i standard except for the AES encryption. And it works pretty good. It's not terrible. The only downside to WPA is that it can be cracked, although it usually takes a while to do it. Whereas WEP, I can punch through WEP in about 5 minutes. For WPA, it usually takes me about an hour or so before I can crack your network. So eventually, the industry, as we keep marching along, the 802.11i standard still wasn't out, but over time they began to be able to have network cards and wireless access points that could handle all of the powerful parts of 802.11i, in particular the AES. And as a result of that, they couldn't call it 802.11i because the standard wasn't out yet, but instead they called it WPA2. If you're going to be setting up a network, you're going to want to use encryption, and you're going to want to use WPA2. WPA2 has some very, very slight vulnerabilities, but it's extremely difficult. I couldn't crack a WPA2 network. So that speaks in and of itself there. All right, so now that you understand WEP, WPA, and WPA2, let's go into our WAP right now and configure it all three ways. Okay, so here I am inside my wireless access point, and right now there's no encryption at all. The authentication is an open system, which is by default what everybody uses, and you can see it says encryption disable. Now this is actually, I don't like this interface very much because on a lot of them it'll just sit here and say encryption, WEP, WPA, WPA2, stuff like that, but this still works out fine. So I've turned on the encryption, which on this system means WEP. So I can either have a 64-bit or 128-bit. Now one of the problems with WEP is that 24 bits out of the key were used for what was known as an initialization vector. So when you say 64 bits, you really only have 40 bits. I'll show you why that's important. Because we're going to have to type in a 64-bit key right now. So I'm going to type in, now this is in hexadecimal, so each time I press it is going to be 4 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. Wait a minute, I can only type 10 characters. Well, actually that makes sense. If it's 64-bit and you can't use 24 bits, that means you only have 40 bits. And each hexadecimal character represents 4 bits. So 4 times 10 is 40 bits. So that's why we can only type in 10 characters. So let me type the same one in. And we hit save, and we have now configured a WEP network. All right, WEP's not good, okay? So we don't want to use WEP, but you need to know this for the exam. So let's go back in, and this time let's look at something a little bit more robust. Now, on this particular weird wireless access point, this is under authentication, but you know, that's just how it is with this guy. So I'm going to go to WPA Personal. Now, WPA Personal, with WPA you've got 2 options. You can do a personal shared key, which means you pass a passphrase between the wireless access point and the client, or you can do what's known as Enterprise. And WPA Enterprise makes you connect to a radius server, which is a very special server that has to be configured, and it handles usernames and passwords and that type of thing. I assure you they're not going to have that on the A+, but they will have WPA Personal. Now on this particular wireless access point, I can pick WPA only, which I'm going to do for right now. And the only thing I have to worry about here is the passphrase. So I type in a passphrase, and this passphrase is not a key, so I can just type in anything I want in here, and it will be a perfectly legitimate passphrase. This is the one downside to WPA, folks, is that short passphrases can make this hackable. So if you're going to use WPA, well, then by all means, try to use as long a password as you're willing to use. So now let's go to WPA2. With WPA2, you can see it's pretty much working the exact same way. The big difference with WPA2 is that it's turned on something called AES. You see here where it says cipher type auto? Now, if I leave it to WPA2, it will automatically set it to AES. If you're not using AES, you're using something called TKIP. TKIP is an improvement on WEP, but it doesn't have the super duper encryption. So I'm just going to say AES because WPA2 means AES. So those are your choices on encryption for an 802.11 network. WEP, tinfoil hat, WPA, not so good. And if you want to do it right, you're going to use WPA2 Personal. And by the way, WPA2 Enterprise requires a whole extra system called a radius server. You're not going to see that on the A+, but you will see WPA2 Personal.